Okay, we're on A2Pure Maths. We're in Unit 5 and we're looking at functions. So we're going to take a quick look at inverse functions. So consider the function f to be defined by f of x equals x plus 3 with the domain 1, 2, 3. The range then, of course, is going to be 4, 5, 6. We want a function f to the minus 1 called the inverse function, which is domain 4, 5, 6 and a range 1, 2, 3, such that f to the minus 1 of 4 gives us 1, f to the minus 1 of 5 gives us 2, and f to the minus 1 of 6 gives us 3. It's of course a function that then kind of takes you back again from the original point. So if f of x is x plus 3, takes you from here to here, then f to the minus 1 takes you back again. In this case, it's easy to see the inverse function f to the minus 1 is given by f to the minus 1 of x is x minus 3. However, in some examples, it's not quite as easy to identify the formula for f to the minus 1s. For this reason, we require a technique to find such a solution. Consider the function y equals f of x, whose mapping drawing is shown below. So f of x gets us from here to here, and then f to the minus 1 y then gets us back to x, so our function f to the minus 1. We require a function f to the minus 1 such that f to the minus 1 of y gives us x. In other words, we require x to be expressed as a function of y. Therefore, a useful technique for finding the formula for an inverse function is to let y equal to f of x and rearrange for x. It's quite a straightforward way in the end. In this example, let y equal x plus 3, rearranging for x gives x equals y minus 3. In other words, if we're given y, the corresponding x value will be find x equals y minus 3. Therefore, the inverse function is given by f to the minus 1 of x minus 3. The function f of x is x minus 3, an example of a one-to-one function. Therefore, the inverse function is also a one-to-one function. However, if we attempted to find the inverse of a many-to-one function, we'd have a one-to-many mapping as the inverse. But one-to-many mappings are not functions. It's for this reason that only one-to-one functions can have inverses. If a function f has an inverse f to the minus 1, then the composite function f upon f to the minus 1 is given by f to the minus 1 of x equals x. If you sub a number into the inverse function and then sub it into the original function, it should get you back to the original number. That's effectively what the inverse function does. Let's take a wee look then at example 1. The function f is defined by f of x equals 5x plus 4. Find f to the minus 1 of x and verify that f upon f to the minus 1 of x gives us x. So to find f to the minus 1 of x, we're going to let y equal 5x plus 4 and rearrange. For x. So how are we going to do that? We're going to take away 4 from both sides and then divide by 5. So that's going to give us x equals y minus 4 all over 5. Therefore, the inverse function f to the minus 1 of x is x minus 4 all over 5. Let's take a wee look then at our composite function. That's what this asked us to do. So it's f upon f to the minus 1 of x. So f upon f to the minus 1 of x is equal to f upon x minus 4 all over 5. So we exchange our x in our f function for this. So 5 upon x minus 4 all over 5 plus 4. 5 multiplied by this gets rid of the 5 here, so we're just left with x minus 4. X minus 4 plus 4, of course, then just gives us x. Therefore, f upon f to the minus 1 of x equals x as required.